Today's podcast is on decomposition of fractions. This is a technique you will use in calculus in a process called integration by parts. When we decompose fractions, we are actually trying to separate it back into the original fractions with different denominators. For example, 7/15 could have come from adding 2/5 plus 1/3. The first step in decomposition of fractions is to break the denominator up into its factors and choose variables to represent the numerators. I usually use A and B. The next step is to eliminate the denominators by multiplying through by the lowest common denominator. That will actually be the original denominator. Then after we do this, we can break the equation up into a system of two equations. One of them will contain the variable x, the other one will not. After this, we will actually solve the system using your choice of method, either substitution, elimination, matrices, graphing, however you choose to solve a system of equations. And the final step will be to rewrite the fraction using the actual values we found for A and B. Let's look at our example. In our example, we were to decompose 6x minus 2 over x squared minus 3x minus 10 into its original parts. First, I did factor the denominators, x squared minus 3x minus 10, factored x minus 5 and x plus 2. I also broke it up into the two parts and wrote it as a over x minus 5 plus b over x minus 2. In the next step, you can see where I multiplied through by my common denominator of x minus 5 and x plus 2. Notice everything cancels on the left. On the first one, only the denominator cancels and the other denominator gets multiplied by the a. And on the second one, only the denominator gets canceled and the other denominator gets multiplied by the b. This takes us right back to that shortcut that I taught you for adding complex fractions, the crisscross. Now, on the next line, all I did was I rewrote the problem without the denominators and then I distributed through. So I ended up with 6x minus 2 equaled ax plus 2a plus bx minus 5b. Notice on here that the green parts do not have variables, but the black parts do. That's how I broke this up into a system of equations. And the reason I can do this is the addition or subtraction property of equality that states that when you add equal things to equal things, it stays equal. In other words, you're keeping your balance the same. We can kind of check this by just looking at this portion of the problem where I broke it up. If you added 6x and negative 2, we get 6x minus 2. If you add ax plus bx to 2a minus 5b, we get the ax plus 2a and the bx minus 5b. So all the parts are there. Now, to make this into a system I could solve, I needed only two variables, and I had that extra x floating in there. But since it was in each term of that statement, I was able to divide the x out and ended up with the equation 6 equals a plus b and negative 2 equals 2a minus 5b. Now I chose the elimination method to solve the system of equations because I'm very fond of it. You're welcome to use any method you want, substitution, whatever. I chose to eliminate the b's, and since this was a negative 5b, I wanted to turn the b in the numerator into a positive 5b so that when I added the equations together, the b's would eliminate. So you can see I multiplied both sides of the first equation by 5. That gave me my new equation of 30 equaled 5a plus 5b. Now when I add the two equations together, the b's eliminate, and I ended up with 28 equaled 7a, or a equaled 4. Then I substituted that back into my original equation, the one that was easiest. You can see where I put the 4 in place of the a, and I ended up with b equals 2. My final step was to make it back into the original problem. So I had 6x minus 2 over x squared minus 3x minus 10 equals 4 over x minus 5 plus 2 over x minus 2. Now, had you reversed the denominators at the very first step, everything would have worked exactly the same, except your a would have been 2 and your b would have been 4. You still end up with the same two fractions. Go to the next page and try the practice problem. Pause the podcast and then go back in and check your work at the end. You could actually check your problem just by going back and doing the quick little crisscross check. 2 times p plus 1 is 2p minus 2. P plus 1 times 1 is p plus 1. And if you add those two things together, you do get 3p minus 1. So my final answer was 3p minus 1 over p squared minus 1 equals 2 over p plus 1 over p minus 1. This concludes the podcast on decomposition of fractions.